Thank you very much for joining in today here. It's such a pleasure to see physical faces again. I spent too much time on Zoom. It's been crazy, so happy to be here. Thank you very much to TBS for having me. It's been a very smooth ride. I remember I just sent a message to Muhammad, and overnight we got the whole thing set up, so thank you for that. And I also want to thank Kauthar, who's not here today for emergency reasons. I also want to thank Abdallah and the TBS crowd for doing the whole work. Okay, so as you probably know, today's session is going to be about the security and governance for the whole Web 3.0 topics. I'm sure that you guys heard a lot about Web 3.0, okay? And we want to really delve deep, and we want to tackle the whole subject from a security perspective and from a governance point of view. Because I feel as a technical person that there's a lot of things that should not be online. I think there's a lot of people that sway the direction of what Web 3.0 can really deliver. So that is for the session today. I'm not going to spend much time talking about myself, but my name is Ameen Al Tajer, as you probably know. You can check out my work at ameenaltajer.com or on social media. I post a lot of educational videos whenever I have the chance. And I run a business named InfiniteWare. We are an AI business, and we've worked with a plethora of clients across 12 or probably 14 years by now. I lost count. I'm getting old. And yeah, so the session today is going to be about those basic pillars. We're going to be talking about a small reality check before we go ahead. And also we're going to be talking about what decentralization is. There's a lot of hype, a lot of excitement happening in that space. And we're also going to explore this topic of consensus. And then we're going to segue just a bit to the history of Bitcoin and Ethereum. I promise we're not going to spend much there. I'm sure you're probably fluent with that by now, sorry. And then we're going to discuss the security and governance, which is the gist of this talk. And then we're going to talk about the challenges and some of the applications as well before we say, before we say goodbye. So, everything good so far? Yeah. You guys are shy, or you're awesome? Okay. So this is going to be an interactive session. I'm not just going to talk and you're not just going to listen. Who here, by the show of hands, believe that Web 3.0 is really horrible? Nobody? You're all pro crypto, I'm guessing, huh? Probably because of the session that happened yesterday. Okay, so nobody here thinks that crypto is really bad. Web 3.0 is really bad. Decentralization is not really good. Okay, so we have one. Okay, getting close. This is awesome. Anybody who wants to share? Okay, this is going to make my job much easier then. Okay, awesome. All right, so let's do a bit of sanity check first. Now, whether you like it or not, we can't really disagree that crypto is a big thing, yes? Across the last couple of years, a lot of hype has been built around Ethereum, Bitcoin, Cardano, you name it. And we also have an exchange here in Bahrain for crypto. You probably know that. We have Rain, and we have Binance coming, and we have also CoinMina. So a lot of cool action is happening. So we can't deny how important this is. Now, Bitcoin and Ethereum specifically are really a refutable testament to where we are right now. We spent more than 10 years now from the moment that, more than 10 years actually, for Bitcoin to where it is now currently. So there's a lot of things that have happened across the years. And the one truth that you have to understand is that hindering the adoption of crypto is really viable. You can really make it slow. You can really make it hard for everyone. But the one truth, again, is you can't really stop it. And I'm going to explain that. And if you're really interested in the technical details as well, please let me know, because I'm actually a technical person and I would love to really shed some light on those topics as well. But the gist of topic today is going to be an executive sort of background. So even if you're not really that technical, you're going to be able to follow up. And last but not least, granted, there's been a lot of scams online. Yes, we heard about sophisticated Ponzi schemes, sophisticated pyramid schemes happening in the crypto space. Yes? Who here had a very bad misfortune? By the show of hands. Okay, awesome. Okay, all right, cool. Okay, all right. Now the crowd is moving, okay. Maybe you're not just used to the physical action, huh? Okay, so, a bit of stats here. The market cap for Ethereum is 190 billion USD, which is crazy, for something that started around 2015, 16, or 14. And the Bitcoin market cap as well is, as you can see, for 403 billion USD. Astronomical amounts, really crazy numbers. And so you can get a bit of action of what's happening in here. This is basically the top list for the crypto action that we have online. So Bitcoin comes first, and then you have Ethereum, and Tether comes in, and USDC, and a lot more. So this really brings the question, now what is really decentralization? What is it all about? What is the definition of decentralization? Why the heck am I speaking a lot about decentralization? So if you really want to put it in a single term, in a single sentence, it's basically the magic of having a peer-to-peer action, for running systems. So to make it really simple, if you talk about our existing system, let's think about the internet for a second. If you go to google.com and you click on enter, you're actually going to Google servers, which is a centralized resource. Meaning, if for whatever reason the government or somebody else says, you know what, we're going to block google.com, you're really blocked because it's a centralized resource, okay? Now what happens if we're talking about peer-to-peer action? If we're talking about peer-to-peer, it means that we have a system that runs in a sort of a mutual privilege, or let's say we have a system that has multiple participants in the system and nobody is actually higher than the other person. So they all share the same privileges, they all share the same, basically, trace for the system. Now this reminds me of something that I used to do when I was really young. Who here remember BitTorrent? You know, the torrent action? Okay, now we see now the action is happening, okay. Hello, pirates. Okay. But yeah, this is basically the way it runs in a peer-to-peer fashion. And the beautiful thing about this sort of paradigm is that if you block one participant in the system, the whole action is going to be diverted to the other participants, which is really great. Maybe not from a legal point of view, but it is still great. Okay, so in order to have a decentralized system, let's talk about some of the really most important traits of the system. The first one is, as I said, every participant is actually a peer. So we don't have a server and a client, or let's say a manager, or let's say an employee sort of action. No, we have this sort of standardized format for every participant in the system, and they're all equal. So we don't have an all-governing body, basically. So again, if you think about that internet analogy, basically, if let's say one ISP says you're not allowed to go to that website, you can actually block it because you go through that centralized entity in order to get access to the internet. Now, this doesn't happen in a decentralized system because if you block one point, I'm definitely going to go to the other participants to get that same information. And this happens in a peer-to-peer system such as BitTorrent because if you are not allowed, let's say if somebody blocks a server from giving you the file, automatically BitTorrent is going to allow you to download the file from somebody else without you knowing about it. Okay, now we get to the cool stuff. Now, the whole essence of a decentralized system revolves around this topic of having a ledger. Now, if you go to a bank, they're going to say a ledger is basically this book that has debit and credit, basically all these transactions, yes? Well, in a decentralized system, this is what we call the event book. So any transaction you make, any event that happens in the system has to happen within the ledger. Now, let's take that analogy to Bitcoin. So Bitcoin basically is a big financial system. Whenever you send a message, you send a payment, that happens on the ledger. This is why it's really important for an open system, such as a decentralized system like Bitcoin, is to have that immutability trait. When I say immutability, I mean that you're not allowed to change stuff the second they're committed to the chain or they're committed to the ledger. So far, so good? Now, this is really important because you want to have a fair system. The second you have the ability to change something in the ledger, people will have the incentive to actually go and change stuff for their advantage. And this is the thing that really differentiates Bitcoin from every existing banking system out there. Now, if you're an IT in a bank and you work with IT, you know that they have access to the database, they have access to the application. So there's a lot of room for people to actually tamper with the data, which is not cool. But if you go to a system like Bitcoin, and again, I'm not advocating for Bitcoin, but I want you to see that one trait here, which is the immutability part. And again, this is what we call DLTs, or distributed ledger technologies. Okay, now this brings me to the other subject of blockchain. How come now we're talking about blockchain and we have decentralization? Well, the reality is, as of today, blockchain is the only implementation that facilitates the whole theory behind this topic of decentralization, okay? And the reason we call it blockchain, because in a system like Bitcoin, what you actually do is every time you have multiple transactions, imagine people sending money or receiving money and all of that, they're actually grouped into this concept that we call a block, okay? So a block is a group of transactions. And the reason we have them in blocks is because we want to basically manage the whole throughput in the system. We're trying to build something that allows us to validate stuff. So the reason we have them in blocks because we want to build a system that allows us to verify that data. And this is really important. Now, if you think about it, in a centralized system, you're not going to have a lot of issues making sure that your data is valid because it's being run by one centralized source. So if you open, let's say, Benefit Pay, nobody here from Benefit? Okay, we have people from Benefit, so I have to be extra careful. Okay. Imagine you open a bank application, okay? So we can make it more generic. Now you're putting me on the spot. Okay. We have people from BBK here and maybe nobody here? Okay, I'm good. Let's imagine that we have Bank A. Okay. Okay, Bombasa, great. Thank you for the suggestion. Okay, so if you have a bank and you have a core banking, which is basically the holy grail application that runs within that bank, you as a user, you can't really defy, you can't really put a lot of argument because the system is basically the holy Bible for the truth that is happening in the system. So the debit and the credit, it all happens in there. But if you have a decentralized system, when you have a lot of participants, and when I say a lot, I actually mean millions of participants. Think about Bitcoin for a second. A lot of people are participating. How can we exactly put a system that validates that all of our transactions are legit and nobody is tampering with the system? This is the whole gist of this idea of consensus. So every time you read about blockchain, you gotta hear basically the word consensus. It plays a huge role in our discussion. So we're gonna go into that in a second. Now, if we're talking about consensus, you have multiple algorithms in the decentralized space. But the biggest one by far, which is really horrible in terms of reputation, is proof of work. Care to think why? Anybody? Why is it so horrible? Why the whole world is giving bad rep to proof of work? Anybody has any idea? You got it, energy consumption, which is a pretty big deal. Okay, you know what? I'll take you through a small tour in Bitcoin and Ethereum so you can have the details here before we jump in. So Bitcoin, as you probably know, is a decentralized cryptocurrency. It was created around 2008 in order to have a replacement for the financial system. So if you work in a bank, you're not going to be happy. But Bitcoin was actually there. The inception of Bitcoin, the whole purpose of it was to provide another alternative to the modern financial system. Let's put it that way, okay? So it was created by this pseudo-anonymous entity that goes by the name of Satoshi Nakamoto. Don't let that name really, basically trouble you. It's not a Japanese person. It's not a Chinese person. It's just a pseudonym. And it could be a government. It could be a company. Nobody really knows. And the whole essence behind Bitcoin was, again, to have that sort of, free-for-all, peer-to-peer transacting, basically allowing people to transact in a peer-to-peer fashion, which again has a lot of ramifications if we're talking about anti-money laundering. If you work in a bank, you know what I'm talking about. All the work is really open source, which is a fantastic deal. So again, coming back to the same analogy as the banking sector, if you work in the banking sector, you as a user, you can't really tell what's happening under the hood. You're not allowed. But in the Bitcoin setup, you basically can go to github.com, which is your #1 source for any programmer, and they can see the whole logic in here. So the whole business logic behind how the debit and credit is actually happening, you will find it there. And it's based on C++. You're not going to have a rough time. And so what I want to focus on here for a lot of people, and I want to clear the confusion. A lot of people believe that Bitcoin and blockchain are the same thing. Well, the reality is they're not. So Bitcoin is only a financial application on top of this technology that we call blockchain. So blockchain offers much more. And the funny thing is banks actually figured all of that going forward. When Bitcoin started, the whole purpose was to kill the financial system. Not really, this is a big statement. Let me say, was to offer an alternative to the financial system. But given that there was a lot of basically fear-mongering happening in the banking sector, but all of a sudden people actually started that you can use that core technology that we call the blockchain, and you can harness it to do far more interesting stuff than just finance. And this is basically what we call blockchain. Now, speaking about interesting applications, I give you Ethereum. Now, who here really used Ethereum before? Not only for trading. Have you used it before? Okay, awesome. Okay, so Ethereum basically is a decentralized computer. And the founder, that goes by the name of Vitalik Buterin, you probably know the guy, a Russian gentleman, wanted to take that principle of blockchain and really do something crazy with it. Not only a financial application, he wanted to build a state machine, meaning he wanted to make a global memory, a global state machine, or basically a computer that allows people to build programs on top of the blockchain. You might be wondering, okay, what the hell is happening? Why would he do that? We already have AWS, and here we have crazy stuff that are really efficient. Well, before we get into that, just remember that their code is also open source, which is fantastic. So you can delve deep and see how things work, which is super sexy for a technical person like myself. Okay, let's talk about this important subject, which is smart contracts. Now, if you talk about Ethereum, you can never avoid this topic of smart contracts. If I had to put it in a single sentence, smart contracts are basically programs that run on the chain or the blockchain. Now, you might be asking yourself, why would I do that if I have proper and efficient and really rich infrastructure for computer programs? Well, the reason is, again, if you run a program and if you're a technical person, you know that you can change the logic of the program. If you get a hacker on a server, they're going to know their way through. They're going to change the database. They can change basically the application, the logic, with a bit of reverse engineering. Now, smart contracts, the whole idea behind them is when you deploy an application, you're not allowed to change the logic, which is a very fascinating picture, or fascinating vision, basically. This has a lot of implications. So imagine in government. So UAE is pretty popular for this. They had a smart contract application running on Ethereum where they allow people to store the ownership, basically, for their lands and the real estate. Now think about that. In a setup like that, it's going to be extremely hard, at least in theory, for people to go and hack the blockchain. It's not a single application. It's not a single server where you can just come in and attack. It's a network. So if we're talking about a network such as Ethereum, imagine you have 1 million users having the same application or the same, basically, Ethereum application. If you go to a single node or a single computer and you change it, the other 999,000, and the rest, they're going to tell you that you're wrong and you should be expelled, basically, from the system. This is the whole governing aspect of blockchain. Because we have decentralization, it is self-healing and it's self-repairing. So when somebody tries to lie, the system is going to eject you. So far, so good? I'm not moving too fast? Cool? All right. Okay. When you go to theoretical talks, a lot of people talk about smart contracts. Well, I wanted to show you some. This is basically a smart contract, which you can actually see on Ethereum's website. Now, from the look of it, if you're a technical person, you probably can identify some of the words. But again, this is not a technical talk. So what I want you to understand is that Ethereum runs on this programming language that we call Solidity. And it's so easy to pick up because it looks really similar to JavaScript, which is the language of the web. The idea behind that, if you know how to program the web, you're not going to have a hard time building smart contracts. And it runs on this virtual machine across the network. So every machine in the network, in the Ethereum network, when you run basically the Ethereum program, you have a program that runs applications like that on your machine without you knowing about it. And so one intuition that I want you to understand when we're talking about dApps and applications on the chain, when you're writing a smart contract, when you hear people talking about, okay, I have a smart contract or I'm building a smart contract, they're basically building a small program that runs on Ethereum that acts as a backend system that you can write applications next to. So when we talk about dApps, who here heard about dApps before, decentralized apps? So decentralized apps, which are the hype or the craze now, they're basically a web application written in a very popular language like PHP, ASP.NET, anything like that. And then it just talks to this application that you wrote in Solidity. Nothing more than that. So it's pretty straightforward for people out there. Okay. This brings me to this topic of NFTs, because Ethereum was actually the whole boat that allowed this NFT craze to happen. And you can see from my voice that I'm getting really agitated now. Okay, so CryptoKitties was an application that said, you know what? If we have this sort of computer that is global, how about we create an application that allows people to have ownership over digital stuff, okay? So CryptoKitties, what it allowed people to do, allowed them to basically mint, again, quote unquote mint, basically do custom cats where different traits that you can never replicate, and people can actually get a hold of that. They can own those things. And this is really fascinating because a lot of people don't understand the meaning behind owning NFT. When we say owning an NFT, it doesn't mean that you're the only person that you can see that image, for example, if we're talking about monkeys or cats. You're the only person that has the copyright, let's say, or the right to that specific asset. So there's a huge difference. And this is where we have people going like crazy, buying monkeys and buying cats that nobody cares about, yes? And one of the biggest things that really added value to that sort of craze is OpenSea. Who here knows what OpenSea is? You guys know? So OpenSea is a marketplace that allows people to go and buy NFTs. Now, the reason I'm giving you all of this really long story is because I want you to understand the difference between two consensus methods that have to be used in the blockchain space. The first one is, as we said, called proof of work, remember? Proof of work, really heavy on consumption, allows you to allow all of these nodes or the core systems in a network like Bitcoin to really agree on what's true. What is the golden source, or let's say the event order, for the transactions. Imagine I'm a hacker, and I really am a hacker, okay? I go in and I say, you know what? Ameen sent 500 BD instead of 1,000 BD. In order to really do that change in the blockchain, I have to have a lot of compute power. This is the whole essence of proof of work. And it's making people really suffer computationally and also economically when they want to go that route. This is why if you play fair in the Bitcoin system, you're not going to have a lot of trouble. Now, proof of work, as you heard, is really bad for the environment. This is why Ethereum now said, you know what? Let us stop here. We're going to switch gears, and we're going to go through a system that we call proof of stake. Anybody here heard about proof of stake? Awesome. Okay, so before I delve into proof of stake and the difference between proof of work, a proof of work, as I said, is fairly simple. It is the one really awesome quirk in Bitcoin that allows Bitcoin to work. When people mine, what they're actually doing is they're trying to search for a very big random number. This is the honesty behind it, by the way. It's a puzzle. It's just a game. A lot of people are competing in that game. So if you find that specific random number, and remember, when you have a huge search space, it's going to be extremely hard to find that number. So what do people do if you have a huge search space? They basically have multiple groups, yes? This is why if you mine, you probably heard about the word pools, yes? The whole essence behind pools is just to have different groups or different packs working together in order to find that number. And then they can split the reward. What they don't understand, those miners, or the majority maybe, is that you're actually allowing the Bitcoin ecosystem to work by doing mining. It's not just making money. You're doing the exact validation of the transaction. So when people send money, you're actually saying, oh, Ameen has balance, so I'm going to allow him to do that transaction. Oh, Ameen doesn't have balance. Let me stop you here. That work, that validation is being done by the validators or the miners themselves. So they're not really just making money. They're doing essential work, but the majority of them don't know. Now, our problem with that sort of scheme is that Satoshi Nakamoto, this pseudo-anonymous guy or girl, we don't know, said, you know what? If I am a hacker and I want to break the system, I want to change the reality of it, I want to give myself more money, I'm going to have to spend more electricity, more power in order to change the truth. It might not be economical. So this is the whole essence of it. If you spend a lot of power, it might be you're going to pay a lot more in electricity fees other than the money that you're going to get. But the reason a lot of people got the hype to do it in Bahrain, because you guessed it, Bahrain has cheap electricity compared to the West. Maybe not for long, but at least for now, okay? This is why the people of Ethereum said, you know what, we're going to switch to proof of stake, which is this new idea of doing consensus, of allowing those machines to really agree on the golden source of the truth and the event book of the ledger, who has what, and the order of the events. Now, if I want to do a comparison, it's very straightforward. Proof of work, you have to put more compute. You have to put more power. This is why, especially the youth, they go crazy about miners. They buy these really expensive devices, 8,000 BD or 9,000 BD, with the whole promise that you're going to really break even in a year. Well, hopefully, if proof of stake really flies, you're not going to have that much time in order to break even. It's really expensive, as you know, and it spends a lot of electricity. There's a lot of power being spent. And as we said, it's basically a puzzle that all of these computers are fighting over in order to reach to that specific number. And again, as we said, it's extremely bad for the environment. So Ethereum figured that, you know what, let's be awesome and let's do things that Bitcoin can't do. How about we switch to what we call proof of stake? And the idea behind proof of stake is different. The idea is the more you put money in the system, the more that you're going to have stake. Meaning, yani, if you have a lot of money, you can't afford to lose that money because you invested a lot in that system, yes? So you're not going to be in that position where you play adversary and you want to change the system to your advantage. If you do that and the system gets you, you're going to be slashed, again, quote unquote slashed, or you're going to be penalized, meaning basically they're going to take your money or the majority of it. And so this is really where the whole community for Bitcoin and Ethereum differ. Bitcoin works as a cult, sadly, for now. They're all about hodling, hodl again, which is I'm not a fan of. Basically, just keep the money, don't move it. We're going to give that ticking bomb to somebody else, and we're going to make money. But the reality is, if you think about economy, you have to have that inflationary tool in order to have value for people to transact. If you have deflationary currencies, such as Bitcoin, and we know that Bitcoin has 21 million Bitcoins, yes? And they don't basically increase. It is the same number is going to be fixed until the end of time. With that kind of mindset, people are not going to have the incentive to move the money. They're just going to hold on to it. And this is the problem with Bitcoin. Bitcoin was never done for it was never done for an economy to prosper. This is why people make money in Bitcoin, because if you leave it now and you come to it maybe 10 years later, you make more money. But in a system like fiat currency, let's think about the USD, for example, the US dollar. If you don't move your money, you're basically losing value, you're devaluing your money. This is why it's extremely crucial to have a cryptocurrency that has inflation of some sort. Okay, the reason I'm saying this here is because Ethereum on the 15th of September, which is almost, is it 20 days from now? Yeah, almost 20 days from now, is going to switch to proof of stake. So this is really a huge step in the whole cryptocurrency community. The people that talk about how this is really bad for the environment, they're basically going to shut up at that moment. Okay? So let me give you a couple of highlights about the Ethereum merge. This is what they call the merge. So the merge is this big move from proof of work to proof of stake, and they're trying to have an existing system that runs on proof of stake that they call Beacon, get to this main basically chain. And the beautiful thing about this is that you as a user, you wouldn't do much. You're not going to have to change anything. You're not going to do anything. Everything is going to be just seamless, and there's zero downtime for the merge. So they're basically better than most banks when it comes to upgrade. Now, misconceptions, and this is where a lot of people have to understand the scope of proof of stake. It's not the end game. It's not going to solve everything, but it's going to solve a lot of stuff. The first thing is, things are not going to be faster. Let me ask you a question. Who here used Ethereum? Let me just do a bit of QA. What is the number one issue if you buy an NFT or you want to send an NFT? What's that? Gas fees. You said it. Now, for the people here that have no clue what gas is this essential currency on the Ethereum network that you have to pay when you want to do a transaction. You want to move an NFT to somebody else, you have to pay. You want to buy an NFT, you have to pay. That thing is really high for a reason, because that is your scalability barrier. When you have a lot of people joining in that Ethereum network and they want to do transactions, the system can only hold so much. So it gives this sort of throttling mechanism, and it says, if you pay more, I'm going to service you faster. If you pay less, you're going to have to wait. This is why gas fees is just so high in Ethereum, and we can give credit to who? Who do you think? The whole NFT craze. Okay? The second thing is, it is really going to be better for the environment. So it's going to slash 99.95 out of the whole compute that we used to spend. So this just shuts the hell up of everybody that says blockchain is really bad for the environment. It's not really the blockchain, it's only the consensus method that we're using. Cool? Now scalability is a different deal, so we're going to delve into that. And this really brings me to the essence of this talk. A lot of people believe that our internet, our beloved internet, really needs a major overhaul. maybe we spend too much time on the internet, not really caring about fixing it for the long run. Okay? So Web 3.0 is this view for a lot of technical and hackers where they say, you know what, we're done with identity theft. We're done with data leakage. And I have cybersecurity experts here that they have their fair share as well. Hacking breaches, ownership, and a lot of crazy stuff happening, yes? Well, Web 3.0, at least in theory, resembles a new internet where you as a user can have a tighter control over your stuff, over your data, over your compute power, over your choices. So this is one of the photos that a lot of people put in their slides, and I'm not going to be different. If you want to track the evolution of the web, it happened like that. Who here is an old guy? You know, somebody from purple? Okay, I'm sorry, wrong question. Okay.
I would never lift my hand up.
The definition is different for everyone. Okay, good one.
It's like saying a lady or a fat.
You want to say somebody?
I'm not going to comment. Now we're getting into politics. Okay, so back in the day, I remember when my dad brought the internet for the first time in my house, I remember we used to have a lot of systems, but the browser was the most exciting things. We used to have static pages. So maybe for the youth here, I'm not sure if you guys remember that, but we used to have websites that you just can scroll over. You can't do much. You can just read and you feel excited by the end of the day. What happened is when we moved to this so-called Web 2.0, things have changed. Now people have the ability to interact. Facebook, Twitter for all you folks there, Snapchat, you name it. Everything happens in that space. But what is that number one trouble, the number one hurdle that we have currently with the internet? Anybody curious to answer? What's that?
Connection.
Not the connection. As a user, where do you really suffer in that internet? Privacy. You guys said it. So in an internet where everything is being run by the cloud, and I'm sorry, AWS, but in an internet where you have the cloud happening and you have that sort of excitement, you as a user, you don't have much. Now, when you go to Facebook and you say, you know what, I'm going to delete my account, you guys really think that Facebook is going to honor that deal? Just be honest. Are they really going to honor that deal? Maybe after GDPR came in, things are going to be changed, but I tell you for sure that Facebook and Google, their business models run on your data, so they're not going to change much. Now, the essence of Web 3.0 is having your data for you as a user under your custody, which means if you want to access a website, you give your permission to the website so they can access your data. It's not the other way around. Now, if you want to escape the system, you can't. Well, with Web 3.0, you'll be able to. Okay, this is the ranting session now. Okay, I'm going to start ranting, so bear with me for a second. So who here talks about the metaverse? Sorry, I know I'm going to lose a lot of crowd here today, so I'm sorry about that. So the metaverse is one of the cultural results of this Web 3.0. And if you really delve deep, you're going to see that Facebook, or Meta, as we call it today, is really trying to have a different business model because of all the cybersecurity stuff that have happened, yes? So metaverse is not really new. I used to play on my PlayStation Home, and there was a game called Second Life for the old folks here. You might remember. So metaverse is not really that new, and VR and AR are exciting, but nobody wants to spend in that virtual space 24 hours with that thing over their head. Let's be honest. So it might not be efficient yet. And there's also one misconception that it's really horrible, that the clouds are going to die soon. No. The blockchain is not going to give you an alternative. The blockchain is solving a specific problem that we're going to delve into. But it doesn't mean that AWS business model and Microsoft Azure and GCP are just going to go down the drain. No. It's definitely no. Okay. So this brings me to this subject. I mean, you're talking too much now about Web 3.0, and it seems that you just dream about that topic a lot. Now, what should I do as a user, or let's say as an institution or as a company, in order to have that Web 3.0 topic really fly? Well, in my research, I've actually summarized those into three main areas. The first one is you need proper governance. The second is you need security. This is why you're here. And the third, which is really crucial, you'll need scalability as well. So let's delve deep into each one of those. Again, is the pace okay, or am I going too fast? Cool?
That's very good.
Cool? Awesome. Break for the soldier. Okay. Security first. Now, if we're talking about security, In the blockchain space, there are a few elements that we have to really master in order to have a secure system. The first thing is you have to have an identity system. Now, if you go to any ministry in Bahrain, you probably have your CPR, okay? And the CPR basically represents your ID to the system, to the institutions that you go to. Well, how do we do that online? We have accounts. We have Gmail, we have Yahoo, and all these things that we have online. Again, the problem is these servers are federated, which means they're owned by their services. So imagine you're Trump, okay? You're Team Trump, okay? And for all of a sudden, Twitter doesn't really like you. They block you, so you can't use your Twitter account to log in someplace else. And this is the problem with federated, basically, identity models. Encryption also has to be really big. It has to be top-notch in order for things to work. And also, by definition, we have to have a proper digital signature system. So let's just go through all of them really, really fast. Now, in a blockchain system, you have to understand how the ID system works. In Bahrain, imagine you have an ATM card, and for whatever reason it's lost. What are you exactly going to do? You're going to call your bank and you're going to say, issue a second one for me. You can do that because you have your identity system that you already established with the government, and you can prove to them that you really are who you claim you really are. In a blockchain system, you are responsible for creating your own identity, which is really fantastic. It's sexy, but it's so difficult. So when you create your own identity, basically, you're responsible for it. If that identity is lost, nobody is going to help you. And this is the really harsh truth if we're talking about blockchain. A lot of people mine Bitcoins and everything, and they get back to it after a year or two, and they say, oh, I lost my wallet. Well, you can't do much of that case, because you can't go to a bank, you can't go to the government. The system runs over cryptography. It uses technology to offer that system, so nobody is there to help you. And also, it's really important to clear one thing in here. A lot of people have doubt on the blockchain space. They say, you know what, Bitcoin is really bad. A lot of hacks are happening. Bitcoin itself, as a protocol, doesn't have the issue. The issue happens in the way people actually use the system. So you probably heard about Mt. Gox, a lot of exchanges online where they get hacked and people just steal every single dime that is within that specific exchange, yes? The problem is, and I like that analogy, it's like when you go to your house, you lock the door and you keep the key in the house. But when you go to the mosque and you want to pray, you keep it outside and then you pray and you come back. So a hacker can just take all of these keys and run happily. This is exactly what happens in an exchange system, like Crane or any of those. When you have a system where you use Bitcoin and you have that money stored in that specific service, it's like giving them your key. So this is the number one issue. The blockchain system was designed in a way to have you as the owner, as the custodian to that system. So what I advise a lot of people is, when you have your money in an exchange, always send it to your private wallet. Whether you have a hardware wallet, whether you have a software wallet, always bring it to yourself. Because if that exchange is hacked, you're not going to be impacted. Cool? So far, so good?
Not very cool.
Not very cool?
Let me ask.
Hit me.
Now,
There you go.
now you said you put your money in the exchange.
Yes?
So our comment said that.
Yes.
And now you want to move it to your private
Mm-hmm.
wallet. So does that remove it from that exchange or keep
100%.
or it keeps a copy of it?
No, the key is still going to be there, but you're taking the funds to yourself. Which means if a hacker comes in, they're going to have your private key, but they're going to say, oh, this guy has only 0 Bitcoins. It's not exciting.
And Rain, for example.
Yes.
Okay. So what's the purpose of Rain then?
Rain allows you to exchange. They're not.
I remove everything. I finish my deals.
Yeah, this is exactly the ideal way of doing things. You're not supposed to leave your money out there. If you leave it, you defy the whole purpose of having a decentralized system. So we're back to this federated setup. Am I right? Thank you, Adi. Good question. Good points. Okay. So in a blockchain space, the beautiful thing is you have a global identity that you can use across all of these systems, and nobody can block it from you. This is what is so sexy about the technology. And for the people who are really interested in knowing how things work, basically when you create a wallet, imagine I'm in Bitcoin, I'm interested in really transacting. When I create basically a wallet, I get two things. I get what I call the public address, and I have what I call the private address. Now the private address is private for a reason, because the only person who has to have access to that is yourself. Now the public is really close and similar to this Bitcoin address, the thing that you can share with your peers when you want them to send you money. But remember the whole goal behind the private key. You don't share it with other people. The problem as of today, we don't have enough culture and education when it comes to managing our keys. If you go to a corporate or a business or a bank, they'll know how to do it. And they're actually pretty crazy about that. They have things like HSMs, hardware devices, dedicated to having and storing those keys. In fact, there's a standard called FIPS, if you heard about FIPS. If you just shake that box that has the keys, it's going to delete itself. Think about that. This is crazy. But when we're talking about end user usage, if I have a specific wallet on my machine, I'm going to treat it as a program. I don't care about it. But if you have enough money, people are going to target you. And I personally know Bahrainis that have 100,000 BD worth of Bitcoins in their addresses. And they're using it as if they have basic setup, and they don't have proper security for it. So this brings me to the other subject. Hardware security is really, really important. And it really works super well with the blockchain. So you can get basically a hardware wallet, like a Trezor or a Ledger, one of those things. And the beautiful thing about that is that that specific ledger, that specific piece, has a small computer inside. It's going to allow you to put your private keys inside. And whenever you want to do a transaction, there's going to be an exchange between your computer and that specific device that you put, where you have to offer the PIN code. And this is really beautiful because you're segregating now authority. If a hacker comes into your machine, they're not going to be able to steal your wallet. They have to steal the physical wallet and know your PIN code. So we're getting somewhere, yes? A bit of advertisement, sorry. Now, if you're interested, you can go to my YouTube channel. I have a very long video, long in the sense that it's 10 minutes or 5, I believe, where I talk about how those devices really work. And if you're a hacker, you probably are going to be interested in knowing how to do reverse engineering, which means how to really decipher those devices and dump the firmware inside, okay? So go to my Instagram and you can exactly see that. Now, this brings me to the subject of digital signatures. Now, digital signatures, just like when you sign something in the real world, a blockchain also relies on your private keys in order to allow you to prove that this transaction was signed by Ameen. Ameen approves that this really happened. Nobody can claim ownership or, let's say, credibility for doing the things that I do. And I'm not going to spend time on the technical things in here, but I want you to understand that there's a lot of cryptography, hence the word crypto in cryptocurrency, and there's a lot of hashing, a lot of really cool stuff happening. Okay. Now, in a regular setup in a blockchain, one of the things that really is one of the really important things that is making it very, very solid against hacks, the protocol itself, is that when you have a lot of transactions and they're bottled, let's say, in a specific block, and that miner gets that money for that specific block, imagine you mined, let's say, 6 blocks. If I am a hacker and I want to change a transaction that belongs to the first block, I'm going to have to mine and find that specific random number 6 times, which means I'm going to have to spend more electricity. So by nature, the design of blockchain was done in a way that you have to put more electricity, more power every time you want to change something in the history. This is why it's like every user in the blockchain space are synced. They're all moving together. So if you want to change something in history, you have to run faster. You have to change things and put more effort, more electricity to go there. This is why, according to Satoshi Nakamoto, it's not going to be economical for you. You're not going to spend $1 million, let's say, in order to have a transaction that says that you own $400,000, for example. It's not going to be fruitful for you. Other than that, I want to clear also one misconception that happens, especially in Bahrain, where people get crazy and excited about blockchain. There's a huge difference between open blockchains and private blockchains. Who here heard about private blockchains? Consortiums. What is your opinion about those guys? Do you guys love them or you guys hate them? What's the deal?
It's good for the government entities as well.
It's for government entities because of the hype, yes?
And also for maybe the big institutions. I don't know what it will be.
Generally, banks, they go on the wagon because they want to experiment. But everybody else, they share the same sentiment, or you guys have different opinions? What's the deal today? You guys are shy. What's that? Internal communication? Yeah, that's true. That's very true. What I want to say here is that there's a huge difference. Open blockchains, as we call them, like Bitcoin and Ethereum, their main essence is having too many players in the system. When you have a lot of people, when you have a single adversary, all of those people are going to exactly expel that adversary from the system. They're going to say, you're not playing fair, just get the hell out. But in a system where you have 8 players, imagine you have 8 banks in a blockchain. What are we exactly doing? 8 participants? We're not having that ability. We don't have that power of having so many people, you know? It's basically a lifeline for the system. You get the idea? This is why sometimes it's cool to use a private blockchain if you want to do auditing, you want to have a proof that this data came from somebody else, nobody tampered with it. But the reality is Bahrain is super mature. Let's take Benefit, for example. We have EFTs, Fowler and Fowler Plus. These systems, they don't go over the internet for the major part. They have their own private networks, and I'm sorry I'm getting into details here, but they have their own private networks. So if you are a hacker, you're going to have to break into one of those things. You know, you have to break into Benefit. Don't do that, huh? You have to break into their basically premise in order to change the stuff, in order to hook up to the physical network. So what's the purpose of having a blockchain if you're coming back to square one? So open blockchains are really strong because you have a lot of players. If something goes wrong, it's going to self-heal automatically, okay? And this brings us this other subject, which is the 51% attack. In blockchain, who here knows what 51% attack? Okay. The idea behind blockchain is if you take over, or let's say you take control over 51% of the whole node count, or the whole user count, you will be able to lie to the system because you're going to have the ability to tell the other participant that this is the truth, that I have more money. But in order to hack, let's say, 500,000 nodes over the internet, it's going to be a pretty big deal, and it's going to be very hard. So, to summarize the security aspect in here, if you're a user, major crypto exchanges get hacked all the time. Even if they have hot or cold wallets, meaning they have wallets that are only plugged in when they want to do major transactions, they're still susceptible to hack. So you, as a user, remember, it's inherently centralized to use exchanges. Get the money as soon as you can into your private stuff, to your private, basically, wallet. And if you're a developer, the idea behind dApps is very straightforward. They get hacked. Those dApps are getting hacked, like CryptoKitties and all these things. When they get hacked, essentially what happens is a hacker comes in and they hack their JavaScript code or their Solidity code. Any software engineer will definitely understand that you can make bugs. And so if you put an application on the blockchain and you don't audit it, you don't go over its details, you don't double check what happens inside, there's definitely going to be a hacker that's going to abuse that system. And believe it or not, this happened actually to Ethereum. Who remembers the DAO? Anybody heard about the DAO? The DAO hack? Okay, awesome. So I'm going to leave you with 2 pieces of advice here for the security aspect. Never keep your funds on an exchange if you're really real about security, and never keep your keys on a server connected to the internet if you can't afford that. Always unplug that stuff. So let's talk about governance now. How can the blockchain really govern itself? Because remember, the blockchain is basically an institution. It's like a company. A lot of people are working together and they have these systems. So how can you exactly distribute power? Definitely there's going to be a lot of conflict, yes? Well, the good thing is most blockchains are open source, which means not only in terms of the source code, even the policy itself. So a great example is you have people like Bitcoin, Ethereum, and Cardano. They have this notion of improvement proposals. And the idea is just like with legislation, نفس التشريع. You basically have your stuff and you run it by everyone in the community, and if they vote for it, it goes into the system, either automatically or either manually, depending on the applicability of the blockchain. And remember, this is so cool because if you have a new improvement, you don't have to allow people to sign papers. You can send it as a system update. I'm happy about that. Yes. I'm not happy about that. No. You can do that in a really decentralized system. So you have the Bitcoin improvement proposals actually on GitHub themselves. And you can read it. It's basically like a legislation. There's a lot of details on the mechanics, on every single thing inside. And the other aspect, because it is so open, there's a lot of openness happening in that space, you're not really locked into a solution. Now, if you go to an IT, let's say an IT manager or somebody else, their number one hurdle in life when they procure stuff is vendor lock-in. Am I right? You don't want to be locked to a specific vendor. You always have that, you always want to strive for that chance of going and using, let's say, different systems on the same data that you have. This is the problem. Imagine you want to escape Twitter. You think that you can bring your Twitter data to some place else? I don't believe Trump has done that, yes, when he created his social media, The Truth, where he stays there by himself. So what is so beautiful about the open blockchain space is that even wallets themselves, so if you use MetaMask, for example, in order to transact, actually that source code, not for MetaMask itself, for the client, the definition, the roadmap, let's say, or the exact blueprint on how to build something like that is open source on Ethereum's website. Again, the beautiful thing is you're not locked to a specific vendor. Tomorrow you're not happy about MetaMask, it's so easy to build your own thing, and you can also use it with Ethereum. There's a lot of power in the openness of that system. Okay, now there's one thing that I want to talk about, which is so cool, but at the same time brings a lot of conflict in the blockchain space. DAOs are basically distributed autonomous organizations. They're basically a program that allows people to raise funds, to basically ask for funds. Just like if you have your venture capitalist, okay? You're working with a venture capital, and you want to ask for money because you want to do a project. Well, there's a smart contract on the Ethereum as of today that does that. It's called the DAO. The DAO is a smart contract, basically. It is so cool, but there was a small problem that happened maybe 4 or 6 years ago. There's something that goes by the name of the DAO hack. So what happened is a hacker came in and figured out that there's a small bug in that smart contract, and it allowed it to drain it out of money. And I'm not talking about small money. I'm talking about billions of USD, billions of dollars worth of USD. So because everything that happens in the blockchain cannot be changed, the community of Ethereum had to make a decision. Do we exactly do what we call a hard fork? So there's this concept of fork in the blockchain space, which is basically an update. Think about it as an update. Some updates, they're going to just be seamless. Some updates, if you say no, they're going to break the system. This is what we call a hard fork. When that hack happened, the whole community of Ethereum sat down together and they said, you know what? We lost a huge amount of money. What do we do? Do we still keep it with the hacker? Because this is the whole essence of being decentralized. There's no government, there's nobody that can come and rescue you, yes? So the community figured out, you know what? Let's just revoke or let's revert that transaction that happened. But by doing so, they actually split the blockchain, meaning everybody that was on the blockchain said, no, I'm not agreeing to that. They split into a specific blockchain that goes by the name of Ethereum Classic. And then you have the Ethereum, the other one. So what I'm trying to say here, some choices in the blockchain space are so drastic that you're going to have people splitting, that you're going to have trees out of your systems. Not everything is going to go according to plan. So go for it.
Consider this as federation?
Yes, this is federation. But again, there's a small problem with the way they do it on Ethereum and Bitcoin. It's manual federation. Anyway, meaning you have to ask the community either using Reddit or forums before you do the actual thing, which is not cool. Eventually, the whole power is within the hands of the developers, per se, yes? Now, Cardano, which is a very cool thing, tries to overcome those issues. A really great point again. It tries to do this soft fork, hard fork, all automatically, which means even if the developers say no, they're not going to be respected. Everybody that says yes is going to allow the system to change automatically. So this is, in terms of governance, is really a powerful thing. You know that the power belongs to the users. If you're a developer, thank you for your service, but you're not going to own the system. You're not going to take it to the direction that you want.
Actually, over there, it still belongs to the users. You can stay classic or you can go to...
Exactly. You can still do whatever you want, but you're not going to be on board on the wagon for the new people that are continuing the journey. This is why it's called Ethereum Classic. Okay, oops, my God, sorry. Okay, we're almost there, by the way. Let's talk about scalability, which is really important. Now, for the blockchain to flourish, what's the point of doing 6 transactions per second? Think about Visa and MasterCard. When you go to a shop and you swipe that card like crazy, you swipe that card like there's no tomorrow, you can actually have 6,000 transactions per second for Visa, which is fantastic in terms of volume. In the Bitcoin space, if you do a transaction, you're going to have to wait for 30 minutes or 40 minutes. Is that even reasonable? I don't think so. Imagine going to a coffee shop and you tell the guy, I promise you're going to receive your money in 30 minutes. Just take my word. It's not going to really pan out well. So in order to fix that, we have to scale the system in order to allow it to accommodate more transactions, more users. There are a few ways to do it. The first one is to have a bigger block size. Remember in the first slides when I said there's a lot of transactions that you can group in this concept that we call a block? The bigger the block, the more transactions you can put, yes? But that comes at a price, because the more the bigger the size, literally the bigger size it's going to get. So for you to understand with a bit of data, if you now download Bitcoin and you want to serve as a Bitcoin node to power up the system, you're going to have to sync and download 700 or probably 600 gigabytes worth of data. That's a lot of data, just for you to stay in sync with the whole system. It's not so cool. And so when you add more data, you increase that size of the block, it's going to basically explode. So another way of doing scaling, which is a bit hard, is what we call L2 scaling. Now let me take you step by step in order to understand. Now the blockchain that we just explained, this block methodology, is what we call L1, layer 1. You're basically at the ground floor here, yes? This is the most sacred resource. You only want to save what is so important within that chain, because data is really limited. Meaning, if you have 600 gigs resembling all of the ledger data from the inception of Bitcoin, it's still a lot, but we only have transactional stuff. You're not allowed to save names, you're not allowed to save stuff, it's going to explode. And so, because it's limited, imagine we want to run something complicated. We want to build a huge program. We want to do more stuff. We want to do stuff. It's not going to work with the layer 1 setup, because the blockchain is really small. We're trying to be as frugal as possible. L2 is this proposed solution where people and engineers say, you know what? We're going to build another layer on top of the blockchain. So imagine you have Ethereum and Bitcoin that resemble L1 technologies. You're building something on top of them where you can have users and a lot of people doing their work, but in the end of the day, you settle on the L1 layer. You get it? If you work in the banking sector, you know that we have a system called RTGS. Basically, what happens in the end of the day, the government checks with all the banks that, okay, send me your payments. I want to make sure that my records are correct. It's exactly the same concept. You want to do stuff online in a federated way, in a really secure way, but in the end of the day, you want to settle on L1, which is the most important part that resembles your golden truth. So far, so good? Or are you guys lost? Good? Don't be shy to ask, huh? This is really awesome because this allows us to explore more possibilities with the blockchain. As of today, if you want to build something on Ethereum, what can exactly you use? You should use Solidity, the programming language that I showed you. But you can't do much. The bigger the program, the more money that you're going to pay to Ethereum in terms of gas in order to put that smart contract or that program on the chain. Well, a lot of people like myself enjoy programming using C++, for example, and I find it really useful for some cases. So in order to use that, there's a project, for example, called Cartesi that allows you to build much more complicated smart contracts, much more complicated contracts and deals. And you build it in whatever language that you're comfortable with. But at the end of the day, it's going to be somehow connected on the Ethereum, which is beautiful. Okay? So this is basically L2 stuff. Okay, let me talk about the challenges now for Web 3.0 before we go into the applications and we end the session. Okay. In my humble opinion, the first challenge is culture. In order to get mainstream, in order to be mainstream, you have to have a lot of people joining in. This is why, even though I'm not really a big fan of the metaverse and all of that crap, I still find it really key and important for people to really leverage that in order to get their hands on with the technology. I wholeheartedly believe that metaverse, AR, VR is just scratching the surface of what Web 3.0 can deliver. It's much more than that. It's power to you guys, users. But with businesses like Facebook and Meta and everybody else, you have to have that direction happening because this is how culture happens. And people are all for money. Capital talks. This is why you want to embrace that. The second challenge that I find really crucial is regulatory topics. If you're a government, are you really going to give the wheel to some other foundation or some other company to dictate how you're going to operate as a government? It doesn't happen, right? And so we have different goals in terms of the founders in blockchain networks and such. And so government will really have to play a huge role. And we have to give it to Bahrain. And the ability for them to go and really study some of those technologies like Bitcoin and stuff so they can do regulation, legislation is pretty big. It's not easy. And so regulation is going to be a pretty big deal. And third, the applications. Now, NFTs are all the craze, as we said, but can we really build something of value, something that people can say, you know what, I use the blockchain for something really interesting, not to sell a monkey that I have. Go for it. You want that? I can hear you. Okay.
Isn't the biggest risk of this the regulation portion? Because, I mean, like if we're talking about financial institutions, it's not just the government.
100%.
How would that work in the future?
Great question. So what happens is, imagine, take Bitcoin. Bitcoin is not really anonymous. Yani, if you create a wallet and you want to transact, nobody's going to know who you are until that golden moment where you actually bring your money from that crypto space into your fiat currency, into your fiat, let's say, account, yes? Because at that moment, you're going to have to cross the bridge. You're going to have to go from between realms, between two worlds. This is why, if we talk about CoinMe and Bahrain and all these exchanges, they do harsh KYC stuff in the very beginning. They take a photo of your face, and they would like to know your favorite shirt and all these things because they want to know who you are. The reason they do that is because they can track you the second you go out of the system and you've done something really horrible in the crypto space. So that AML sort of KYC thing is really important. And it's really smart of the government to do that. Because if you think about it, a bad person can circumvent that system. They're going to have a lot of difficulties, but if you're just a trader or somebody else, you can do it through an exchange. Why would you go through a lot of hoops, through a lot of dark alleys in order to get to what you wanted? Unless you have something really crazy cooking, yes? But yes, I do agree with you. And regulation is a very big topic. It's not easy to tackle because if you're a government, you want to have policies against money laundering. You want to have governance. You want to have sovereignty. If I give Bitcoin the ability to dictate who can send money, who can receive, what's the point of setting up a ministry for finance to begin with, yes? Or a central bank? Okay, so really hard questions. We're still exploring. Nobody knows what's happening, but we're getting there. And I also want to talk about really beautiful applications. So IPFS, Interplanetary File System, allows you to download a file without knowing exactly where that is. It's really wonderful to use the blockchain to things like that. Cardano is beautiful also. It tries to build an operating system per se to governments. Namecoin as well. A lot of projects that I don't want to go into the details, but just remember cool projects. Okay, let me just finish around here. So one of the interesting applications that I found lately in the blockchain space, are we doing okay on time? Okay, we have 10 minutes.
We'll have some time for questions.
Okay, awesome, great. So you probably heard about DeFi. Now DeFi stands for decentralized finance. It is this whole ecosystem of building a financial system on the blockchain. Again, really sexy, but really hard for Bitcoins to swallow, for banks to swallow. The reason is, are we doing okay?
No, it's okay.
Okay, awesome. So DeFi allows people, or at least the vision is to have a financial system that nurtures itself. You have automatic market makers, you have lending, borrowing, credit, and much more happening on the blockchain. Again, goes back to your question about regulatory. Will regulators be okay with such a thing? Meaning if I want to have a loan, I might not have that liquidity in terms of BHD, but I can have it in Bitcoin, for example. And I can still do things on the Bitcoin space. One other thing that I really love in terms of idea, but I hate the practicality, or let's say the implementation, is the idea of algorithmic stablecoins. The biggest problem with crypto as of today is that you have this fluctuation happening, yes? You bring your money now, after 10 minutes, probably going to lose a lot more. And so because of that, basically, fluctuation, sometimes you have to make really hard choices. For example, in our business, in Infiniteware, there was a moment where we opened our payment gateway to receiving Bitcoin. But we figured out that this was not really a great idea. So what we've done is we automatically do the exchange the second we get the money. But we sound to other people and users that we're really cool. We accept crypto. But the reality is we change to fiat as soon as we can to avoid the fluctuation. And so algorithmic stablecoins are the ability to create coins that are really stable. So they're pegged against something else. And so algorithmic, you probably heard about Solana and the other coins as well. So the idea is nice, building something automated that can really hold on to its value. But as of today, Until today, we still did not get to that stage yet. Okay, crypto has to play nice with the government. So Cardano, for example, is one of the things that I really love because the guy who's behind it, Charles Hoskinson, is trying to build something that is really practical for governments. You can't just live on your own and you pretend that you're going to build a system with no governments involved in it. So Cardano has a lot of applicability and a lot of appetite for governments because they can introduce AML, they can introduce KYC, they can have a wider adoption that way, okay? Okay, so let me give you my final thoughts before I leave you guys and open for questions. Remember, decentralization is really, really awesome. It's powerful. I think for me personally, this is the next evolution for the internet. We are evolving as human beings. We've never had the ability to actually build a system that allows us to contain and have ownership and sovereignty over our data while still working with other systems. We never had that. We never had the ability to circumvent the financial system that is inherently broken. NFTs and metaverse are not the gist of Web 3.0. Remember that. It is cool to have that VR for that 10-second moment where you feel cool, but it's not the ultimate gist of Web 3.0. There's much to it. And it's just a cultural response. And third, last but not least, I want you guys to be safe on the internet. The whole world is changing. If you don't know the basics of security, hardware wallets, you're going to be left in the dark. People are going to steal your money. You're going to be left alone. So be educated in that area as well. And so always remember, the ultimate debate is centralized or decentralized. If you enjoyed that session, I would really advise that you read one of those books. Master in Bitcoin if you're a technical person. You want to read how Bitcoin works inside out using the code. Blockchain also, which is really a nice primer. Also, The Internet of Money by the amazing Andreas Antonopoulos, which takes you by the hand in order to understand how there's much more to blockchain than just money, just trading, that, hey, I made 10 BD today. This is not fun. There's much more to it. If you guys enjoyed the session and you want to have more, I really urge you to go to my YouTube channel. I have topics on open banking, reverse engineering. You're going to find a plethora of stuff, also game development, and there's much more. So here's the YouTube channel. There's a lot of videos. And I want to leave you with that question. You still think that decentralization is bad? Thank you, guys. We can open up for...
Thank you so much, Ameen.
My pleasure.
Really interesting talks. I have to admit that there is a portion of the presentation and the talk I could not digest. I feel a distance between me and what's going on. So this is a message for some of us who works on the technology field to actually get into that part of the dimension of technology and be part of it.
Thanks.
Question for you is, we expect as well the government to have an active role on 3.0.
Sure.
What do you expect from the government to do from service perspective, from how their digital presence, how it should look like?
Yeah.
Do you have any views on that? Thank you.
Sure thing. The founder of Cardano, as I said, is a big believer of the coexistence of government and decentralization. You're not going to be able to go, decentralization 100%. So I ultimately believe that there's going to be decentralized institutions that belong to the government somehow. So you're going to have smart contracts developed by the government that allows for more power, to the user, more anonymity, more privacy, but at the same time, you still want to have that feel of centralization for the government. It's not free for all. It's not the Wild Wild West. So there's going to be, the perfect balance between governance and sovereignty somehow. And to be quite honest, I'm doing my research as well as the other people in that scene. It's very hard to do it, but I feel that Cardano has done a great progress. You can build institutions where you have money laundering and anti-money laundering basically controls happening, KYC, you can have visibility for the government to see. And so I believe there's going to be something in the middle. Not there yet. I don't want to have a very horrible prediction, but we're getting there, I'm guessing. My pleasure. Anybody else? Be brutal.
Thank you for this wonderful workshop. I just had a question. I think as of now, we haven't reached as of now, the number of transactions per second for a Visa is far more than the Bitcoin and the Ethereum. So
That's true.
I think we are still behind. What do you think? How can we increase the number of transactions per second?
Just like what I said in my session, we're exploring scalability solutions. So you have L2 technologies that are trying to take some of the bandwidth outside of the blockchain, but still get some of that governance and security. We're not there yet, but there are some cool topics happening. For example, if you heard about sidechains, if you heard about roll-ups, there are technical topics that allow you to really do a lot of transactions. A great example, go to cartesi.com, that project that I showed here, let me show you. That project can do thousands of transactions per second. And they're allowed to do it because they're going in an L2 setup before they go back to the chain. If you're looking at Bitcoin and Ethereum, we're not there yet. But for other projects, yes, but they rely on it. But again, I completely agree. There's not a single solution yet. There's a lot of ideas, a lot of experiments. Hopefully it's going to be, we're going to have a de facto answer to all of that. Anybody else? Go for it.
Just wanted to ask, what do you think about the crypto mining and
Who's that?
proof of work?
Okay.
Of,
Okay. Now we're talking. Okay. Any fans for mining here? I'm sorry, guys. I love you, but we have to do this. So mining is not going to stay for long in other blockchains, in my opinion. Just like with Ethereum. Ethereum has a mantra. The team behind Ethereum, they have break fast, grow fast, something like that. With Bitcoin, it's so sad that they're operating as a cult. I love Bitcoin, but the modern people, they're all about hodling, Keep the money, nothing is going to change. You're not thinking about the technology, you're doing a lot of damage to the environment. But mining really goes back to that specific point where you have compute. And so what happens is, if proof of stake presents a really valid option for blockchains to switch, everyone will do it. I don't know about Bitcoin, but they're going to do it. So as of today, you can probably mine on the Bitcoin because they're not going to change soon. Remember, they're working as a cult. But if that happens, we'll have to say goodbye to mining, basically, altogether. Because with proof of stake, you don't call them miners anymore. You call them validators. And there's a lot of dynamics towards doing the same consensus. A great example is when you have a lot of money in a system, you're going to lose a lot more when you do something wrong. So the algorithm within proof of stake somehow randomly chooses a person and says, tell me what the answer is. Tell me the golden source now, the golden truth. If you lie, a lot of people are going to say otherwise and you're going to be penalized. But in doing so, you're not doing any compute. You're not spending electricity or power. So we're getting to the same ultimate goal without it. I really hope that mining will die soon. I really hope. Because it's giving a lot of bad rep to the blockchain. And there's more to that. Anybody else? Do we have enough time, Muhammad? Okay. How many questions? 3 or 4? Okay, go for it.
Right. In terms of anonymity, one of the proponents of Web 3.0 is giving people complete control over their identity.
What's that again, sorry?
In terms of anonymity,
Yeah.
one of the proponents of Web 3.0 is giving people complete control of their identity online.
Yeah.
Right?
Yes.
So it's possible for people to have completely different personalities online versus in real life.
Yes, that's true.
Right? So that being said, how is it possible for governments to sort of use KYC to track online activity to real life people?
Very straightforward, very easy. When you download Benefit Pay, sorry, come back to Benefit again. Great. Okay, now I can be as free as I want. Okay. So when you download Benefit Pay, there's this process that we call tokenization. You guys know about tokenization? So basically, there's a way that you authenticate with benefit servers in your bank, and you're taking that credential details and you're putting it on your phone. So your phone is pretending to be your ID card somehow, or your ATM card. The same concept can happen also on the blockchain. So theoretically speaking, the government can write a smart contract where you put your identity card somehow, and then that smart contract is going to have your actual ID card. So you're not going to be anonymous anymore, at least to the government, but you're going to be anonymous to the other public. Okay? But you can do that with a smart contract because you're building software. So you can integrate smart contract with IGA or something like that if you want. But you can do that, definitely. And Cardano allows you to do so, by the way. Anybody else? 2 more questions, maybe? Okay, 1, 2? Okay, 2, and then let's close so we can finish on time.
Thank you for the session.
My pleasure.
I would like to ask about the Web 5.0. Does this type of network resolve all the problems that face 3.0?
You mean Jack Dorsey's project?
Yes.
Look, Jack Dorsey is a very interesting character, the guy who created Twitter, okay? He called it Web 5.0, but the reality of it is just decentralization. So I don't really where he's going to go. I read his paper, I read everything, but I still believe that there are people who have better grasp on their understanding of the tech. Ethereum's folks, for example, Cardano's folks, these people are severely educated on the distributed systems, the academic subjects of building a network of that scale, and on the economics aspects as well. So I wholeheartedly believe that are better people to answer those questions, than Jack Dorsey. Anybody else? Last question?
I think we have a question here.
Okay, we have another one here? Okay, bonus question. You guys want to frame him? Okay. Be brutal, you can. Okay, I think we'll take the question there and then you, okay? We'll close with you.
Thank you for the session, Ameen.
My pleasure.
I have 2 questions.
Go for it. You're cheating. Go for it.
Do you think in future distributed system or distributed infrastructure can be more efficient or scalable than a centralized infrastructure?
Yeah, 100%. I'll give you an example before you go to the second option. Remember when I said the cloud is not gonna die? Well, the reality is if you think about L2 solutions, the scalability solutions that we talked about, in order to accommodate more volumes of transactions, they operate on the cloud. They operate on the cloud. So we're still in that position where we need proper infrastructure like AWS and Azure. But the reality is we're not giving them that power over our data or over our assets. If AWS gives you the boot the day, you go to another cloud provider and you're good to go. They're not going to hold your data. They're not going to be able to see your data if it's encrypted. So the ability to have the migration sort of feel is really powerful for you. So we're still going to be needing those infrastructure, huge infrastructure companies, but again, you will have the ability to go back and forth.
Yeah, the second question is, can we say that decentralized economy will not allow you to do any mistakes?
I'm not an economist, so I'm going to have to skip.
What I mean is, when you talk about the privacy, about you have to store your coins for yourself, what happens if I mistakenly send to somebody else or I use it?
Look,
So there is no basis there to...
in Bitcoin as of today, you can't do much. Even though it's so crazy that a lot of people don't understand that there's a programming language embedded within Bitcoin that allows you somehow to do similar, really basic stuff. But when you have a really rich ecosystem with smart contracts that resemble institutions, that resemble companies, that resemble government bodies, you'll be able to do that kind of maturity, in my humble opinion. You just need time to build it. So if we compare, let's say, a nation like the US, why is the US at least good enough for a lot of people? Because they have institutions that can service their citizens, yes? Just like with Bahrain. So with enough time, proper expertise, people are going to build that heritage. They're going to build that institution set, and people are going to feel like they're in home, that they're basically at home in the blockchain space, I would think. A great guy is Charles Hoskinson, wonderful guy. One last question, is that okay? Awesome.
Thank you.
The most difficult question, I'm guessing, huh?
How will the transaction be validated with the system running on POS?
Okay. So there's a slide here. Just going to go back to that. All right, we're getting there. You guys deserve a trophy. You went through all of that, huh? Okay, so yeah. So proof of stake needs you to stake by definition, meaning you have to put money first in order to operate as a node. Yani not like proof of work where you say, hey, I have a powerful machine. Let me validate transactions because I'm faster. With proof of stake, the more money you put into that safe quote unquote, you'll have more collateral. Yeah, and if you do something wrong, you're going to be in a very bad spot. And so in Ethereum, for example, they're leveraging a plethora of stuff. One of them is proof of stake, and it's actually using randomization as well. So when you have a lot of stakers, it's going to randomly somehow choose one of those in order to tell the truth, and they also use sharding, which means you don't have the full ledger on your machine, just like with Bitcoin. Every guy that operates Bitcoin, they have that 600 gigs worth of data. In Ethereum, because they want to do it faster, you only get a portion of the data. But in computer science, this is really a bad idea. But that guy want to do it in practice, so we'll see. But coming back to your question, proof of stake does that randomly, semi-randomly, let's say. Okay? I think we're done for the day. Whew.
I think so. Thank you so much, Ameen.
My pleasure. I had a great time.
Amazing to have you with us.
Thank you.
We're glad actually that you're a member of TBS.
Sure.
We are looking forward
It's a pleasure.
to more of your contribution.
Always.
Not just event, we'll do more stuff. I'd like to thank everyone who attended today's session. We're looking forward to see you again on a lot of events that we are organizing this year. Please, I'll ask you to follow our Instagram account, TBS Bahrain. And as I can see a lot of students here, I just want to make sure that you're aware that we do have on TBS student membership, where you can join for free, be part of this society, where you can, if you feel that you want to contribute, you want to give something to the country, TBS is the right for you. Wish you all the best. Last thing, I would like to thank you again. So,
Sure.
Applause for our friend Ameen.
Thank you, guys. It's been a pleasure.
This is just a certification.
Okay.
I'm going to take a photo.
مشكور أبو محمد، ما قصرت على الدعوة.
Okay, this one.
تمام؟ يعطيك العافية، ما قصرت. شكرا. Thank you guys for coming. I hope you enjoyed it.
Finally, there is some refreshment outside, so please. It's good to have some networking outside, so spend some time with the group to get to know each other, and then you are feel free to leave anytime.
Thank you guys. حبيبي مشكور محمد. إن شاء الله استانستوا.